T190 that pulls left under load usually isn't a bad drive motor. It's a track someone ran loose all summer. So, which parts on this machine actually break? What do they whisper first, and what does each one really cost you? Start at the ground, because the undercarriage quietly eats more repair money on a T190 than most owners ever expect. Rubber track, drive sprocket, front idler, bogie rollers. 4 parts, 1 chain of failure, and they take each other down. A loose track's first tell is sag. One side hangs deeper than the other while the machine's just sitting there. Sag means the track rides up the sprocket teeth instead of seating in them. Now every tooth wears on one face. Cheap version, grease the tensioner, walk the machine forward, recheck the sag. An afternoon, a grease gun, and you're done. Expensive version, you ignored it, the sprocket teeth rounded off, and now a brand new track skips on a worn hub. Same failure, 2 completely different prices, and the only variable is how many hours you drove it hanging loose. And over-tight costs just as much. A drum-tight track loads the idler and roller bearings every second the machine runs. The symptom: there's a whine on hard ground and a machine that feels like it's dragging a stuck parking brake. The service manual lists the exact sag spec. Measure it. Your eye is biased toward tight, and tight is expensive. Bogie rollers are sneakier. They're sealed and oil-filled, and they die weeks before they ever make a sound you'd notice. The first symptom is a wet stripe of oily dirt smeared across one roller face. That seal's already gone. The second symptom is heat. Shut down after an hour of work, then walk the undercarriage with your hand out. One roller, noticeably hotter than its neighbors, is a bearing eating itself. Today, that's one roller. That's the whole bill. Let it seize and it wears flat. Then it starts chewing the track's inner lugs. Now you're buying track too. That's the pattern for this entire machine. One cheap part failing alone, or one cheap part taking 3 friends with it. Pack wet mud into the undercarriage and let it freeze overnight, and you've built a press aimed at your own idler. 10 minutes with a scraper at the end of a muddy day is the highest return maintenance on this whole loader. Now the genuinely expensive hardware down there, the drive motors and final drives that actually turn those sprockets, their honest early symptom is a weep. Gear oil sweating out around the sprocket hub with dirt sticking to the film. Catch it weeping and it's a seal in fresh oil. Run it dry instead, and you're replacing the entire drive unit. If that just changed what you look at tomorrow morning, that's exactly what this channel is for. Stick around. The other symptom up here's speed mismatch. Both levers full forward on flat ground, and the machine still drifts. Undercarriage, drive motor, or hydraulics can all cause that, and they feel identical from the seat. So don't guess. The manual walks a pump output flow test step by step. That test is what separates them before you spend anything. Above the ground now, hydraulics, and on a T190 the first complaint is almost always the same one. You curl a full bucket, walk off for lunch, come back, and the tilt has quietly crept down an inch. That's cylinder drift, and it's either the cylinder's own seals letting by, or the valve that's supposed to hold pressure. The manual's drift test is specific, and one line in it's a safety rule. Check only one cylinder at a time. Open the rear door, follow the procedure, and treat lift and tilt as live until the pressure is genuinely released. Cheap outcome: a seal kit and a clean bench. Expensive outcome: a scored chrome rod that needs a whole new cylinder. So what scores a rod? A nick from a stump, and 1 season of grit dragged past the wiper seal, which makes wiping the exposed rods before you park it the 5-second habit that saves the 4-figure part. Different symptom: bigger stakes, weak lift, slow curl, a machine that works fine cold and turns lazy once it's hot. Now you're testing system pressure. On this machine, the main relief is approximately 3,300 psi, or 22,754 kPa, and the manual is blunt about it. Don't exceed 3,300 psi. Past that, you're not diagnosing, you're breaking things. You also test warm, never cold. Warm the fluid to 140 degrees Fahrenheit, 60 Celsius, before any number means anything. That's why shops and owners argue. Cold oil fakes a healthy reading, and everyone drives away confident and completely wrong. On the high flow relief, the flow should hold steady until roughly 3,100 psi, then start dropping off fast. By 3,250 to 3,300 psi, flow should be at 0. If it isn't, the relief valve just became your main suspect. Read what that implies. Bad pressure isn't automatically a bad pump. Reliefs are cheaper, and they fail often enough to check. Replacing a pump on a hunch is how a small valve problem becomes the biggest invoice you write all year. Hoses are the other hydraulic weak point. and they fail where they flex and rub, not where they're old. Look for a shiny polished spot where two lines kiss. That shine is a countdown. Separating them costs a zip tie. Now the half of this machine people diagnose worst, electrical where the cheap fix and the expensive one look identical. The single most misdiagnosed T190 fault is a ground. Corroded or loose grounds throw symptoms that look like dying electronics. The manual says it directly. If you're seeing strange behavior, check the grounds before you condemn any control component. Here's the mechanism. A corroded ground doesn't fail outright, it adds resistance. Voltage only sags once current actually flows, which is exactly why the machine acts possessed at full throttle and behaves perfectly the moment a tech is watching. Cleaning a ground strap is sandpaper and 10 minutes. Replacing a controller because you skip that step is neither. Charging system next. This loader runs a 90-amp alternator, and it almost always warns you before it strands you. The first thing to check is the belt. If it's worn or deteriorated, replace it. That's the manual's own instruction. The second check is free. Find the alternator fuse in the fuse panel. If it's burned, find a cause first. A fuse that blows twice isn't a fuse problem. It's telling you exactly where the real fault is hiding. And if the fuse is in doubt, pull it and check continuity. A cracked element has fooled better mechanics than us. Testing further means disconnecting the alternator's B-plus terminal, so kill the battery first unless you enjoy welding with a wrench. Which brings us to the part that intimidates people most, the numbers scrolling across the display on the dash. The hourmeter doubles as the code display. When more than one service code is present, the codes scroll one after another. That scroll is a gift. It's the machine handing you a starting point before you've pulled a single access panel. But a code names a circuit, not a culprit. 3241 is no communication. That's a conversation that stopped, not a dead part. So before ordering anything, do what the manual orders. Check that every connector on the Bobcat controller is locked into place. Then check the pins inside those connectors for pins pushed back or bent. A backed-out pin mimics a failed component perfectly. That's a flashlight in patience versus a control module. Identical symptom on the dash, wildly different number on the invoice. The 32 family covers lift and tilt actuators. 3236 is lift actuator fault. 3231 is tilt actuator fault. Two separate parts. Wiring gets its own numbers. 3237 is lift actuator wiring fault, and 3232 is tilt actuator wiring fault. Read them carefully. One digit apart. Completely different repair, and don't try to decode the pattern yourself. These tables change between machine generations. There's 3249, lift actuator short to ground, and 3251, lift actuator short to battery. Both pointed at chafed harness. There's even 3257, lift actuator reduced performance. That's the machine admitting it still works, just not the way it should. Then 3239, lift actuator not in neutral, and 3240, lift handle or pedal not in neutral. That's a startup lockout. And here's the best one. 3223 is ACS not calibrated, nothing is broken. Something needs calibrating and no part will fix it. Rear auxiliary treble shows up as 23.2, rear base solenoid error OM, or 24.2, rear rod solenoid error ON. Two-speed carries its own pair. 37.2 is two-speed secondary error ON, and 37.3 is two-speed secondary error OF. And solenoids are testable, which is the whole point. The coil should read 9.8 plus or minus 1 ohm at 20 Celsius. Apply 12 volts to that coil and you can see and hear it move. A silent coil with wrong resistance closes the case. Fuel codes trip people too. 99 is fuel level low, while 921 and 922 are out of range, high and low. Out of range means the sender is lying, not that the tank is empty. You're chasing a sender and its wiring. So here's the pattern underneath all of it. Almost nothing on a T190 fails without giving you a cheap warning first. Sagged wet roller, a bucket that crept, a code that scrolled. Every four-figure repair started as a 10-minute look. Walk the undercarriage cold, wipe the rods before you park, read the codes before you buy, and check grounds before blaming electronics. Subscribe for daily diagnostics. Next up, we walk the entire 32 series lift and tilt actuator tree, code by code. The exact specs, sag numbers, and test procedures are in the service manual linked below. Like this if it saved you a gas.